I'm just going to copy control 2 into 3. And example 3.py. And I'm just going to run it so we start at a good point. Okay, so let's go ahead and build a confusion matrix. I'm going to come down to the bottom of my code and build the confusion matrices. X underscore train underscore predict is equal to SGD underscore CLF dot predict X underscore train. And let's go ahead and run that just to get an explanation. Oh. Did I open the wrong code? Classification 3. Oh no. All of my stuff is gone. All right, so let's see what happens if I drag in 2. Okay, let's see what happens if I drag in 1. Okay, that's not what we want. So I have somehow deleted all my code that I just did, but that's okay. We're not going to redo it. I'm just going to open it up from somewhere else. Going to build the model. And that should work now. I'm going to need a few things up here, but that's fine. From sklearn import linear models. I need my X-train, split the data. I need to extract a subset. Okay, I'm going to start again. All right, so building off of example 2, let's build classification matrices, confusion matrices. So return the prediction made on each test. That's going to be x underscore train underscore predict is equal to SGD underscore CLF dot predict x underscore train. And now that should give me an x train predict true and false. That gives me a result for every number. So fives it detected as, so blues it detected as fives or true, and reds it detected as not a 5 or false. And from that, we can build a confusion matrix. So let's just go ahead and print one. Go print sk.metrics.confusion underscore matrix y underscore train underscore 5 comma x underscore train underscore predict. And then that should go ahead and give me a confusion matrix. Oh, needs to be a capital X. And now I have this beautiful confusion matrix. I have 54,389 not fives. I have 38,032 correctly classified fives. I have 1,589 true negatives. 1,589 false negatives, and then I have 190 false positives. So let's do something. Let's say you wanted to interrogate your data a bit more, and you wanted to say, find all the false positives and find all the FP and all the FN. All right, you don't care about the trues. You want the false positives and the true false negatives. So let's go confusion underscore booleans is equal to np dot v stack. Going to stack them vertically. Open and close brackets. Now I need a tuple in it. Y underscore train underscore 5 comma x underscore train underscore pred dot t. And that's going to give me a Boolean of all of my confusion matrix for true and true. And now here you'll find some interesting cases. So it's classified as a 5 and is a 5. And then my other one, it is classified as not a 5, but sorry, it is not a 5, but it is classified as a 5. So that's line 47 is classified as a 5 and is a 5. And line 48 is not a 5, but is classified as a 5. So I can say FN index, that's all of my false negatives, is equal to np.where, again, two parentheses, confusion booleans is equal, nope, there's no parentheses, is equal to a string of true comma false. Because a false negative is when it is actually, it is not a 5 and is classified as a 5. I want to test all for axis equals to 1 and then close out the outer parentheses. So it's a Boolean, and then dot all axis equals to 1, close out the outer parentheses, and then I just want my first list of that. Cannot import name from sklearn linear models. Did I spell it wrong?
I think there's no S.
Linear model. I wanted to run an F5 again just to make sure I wasn't too far having some compounding issues. And then I can do the same. I'm just going to go ahead and copy that. For false positive index, a false positive is going to be the opposite. It's going to not be a 5, but it's classified as a 5. And now this gives me a list of all of my false negatives and a list of all of my false positives. So what you'll notice from my confusion matrix when I reran it, I get significantly different results, right? Before I had a model that had much more, I believe, false negatives, and now I'm got about equal 994, 820. And actually, if we just run it again, let's see what we get. 994, 820. Oh wait, I got to train it. Okay, so let's train it. And then let's rerun my classifier. So it's training the classifier. And now I get 1301, 780, right? So it's a pretty stochastic. So just because mine trains it, mine identifies it as a 5, doesn't mean that yours will identify it as a 5. Does that make sense? So let's just look at a few examples. How about that? For that, I'm going to go grab our plotting code. I'm going to shrink it all up. And let's say plot a false negative. So let's grab false negative index. The very first false negative is 132. And so it says it is not a 5, but it is actually a 5. Sure. Right? I mean, I don't know what to say. Does it look like a 5? No. But I'm told that it's a 5. And then let's plot a false positive, which is 161. So that is a 2-digit. Wait, sorry, where did I get 161? It might not be 161. False positive 48. Oh, 161 is actually the third one down. So that works too. It classified that as a 5, but it is not a 5. So not the world's greatest classifier, right? To me, that's a pretty easy 2. But we did train a stochastic gradient descent classifier that is able to classify. So